quizzes? Good? Good. Straightforward? Pretty straightforward, I'm guessing. Yeah. Anybody do all three?
Yeah.
A couple of you. Good. How many did two? How many did one? Look at that distribution. That's fun. Anybody skip them all? Skip them all? Yeah, that's fine too. Hey, right? That's the beauty. You can skip all of them and just grab them later. That's totally this guy did. Totally fine. I'm going to post more today. I've got one ready to go. I might have two ready to go. I got to build a third one from a Facebook post somebody sent me yesterday. Did I tell you guys about this? Political party affiliations tied to GMO labeling in the country. Really? GMO, genetically modified organism, on food.
Monsanto.
Yeah, it's just great. I haven't even looked at the map yet, but I know, I got a gut feeling about the map by seeing how they did. Well, I can see where the reds or blues are. Yeah, I just don't think, I want to make sure, see, I want you guys to test it for statistical correctness. To make sure that the map accurately portrays what the data actually is. The data's on there, I think. If it's not, I'll find it for you. So, it's on Facebook. I read it online. It has to be true. Yeah, this is one more of those things about don't trust everything you see online or on Facebook or tweeted.
So seeing's not believing?
Seeing is skepticism. That's what hopefully you'll learn in this class. So many people say that I ruin your ability to consume the news. And I don't think it's that. I think what I do is I make you a skeptic. And being a skeptic is not a negative. Right? It's not a negative, it's a cautionary thing. Being skeptical is a good thing, right?
Well, you're increasing scrutiny. That's all.
Right. You're becoming more scrutinous.
Scrutinous is a word.
Is scrutinous a word? Now I've made it up. Scrutinous, yes. You're scrutinizing more. I like that. That's good. It's a good thing. So anyway, let's recap where we were. So we got quizzes up. There's also a project coming next week. Don't forget about it. It sounds like some of you guys are into it already. Don't overthink the math on it. There's not a whole lot of math to do on it. The big idea of that project isn't the mathematics. It's the understanding of the symbolism and probability. Honestly, that's what we're trying to get at. And we're trying to get at not just that, but also understanding what probability means. Now, if you had me for 105, you had a jump start on this, because I tortured you guys with that for like half the term. Sorry. But if you haven't had me, we've mentioned it a little bit already. The project mentions it a lot more, and it's going to become part of our conversation over the next couple of weeks in class.
Just what I needed.
So the project kind of gets you started, and then we're going to merge and take stat and prop together. All right. We played with this stuff on Monday. Number of keys we had. On average, we had some discussions of averages. Averages. How many different kinds of averages did we speak of on Monday? We talked of 3. Describe them for me. Pick one and tell me all about it. Pick one of them and tell me all about it. Or everything you can remember about it. You can use your own words. Excuse me, larynx. Randall, go!
Well, the mean is basically seeing how many each person would have, or each subject would have, if you distributed it equally.
I love this. I love it. If you had a data set with a finite number of data points in it, and those data points had some kind of a quantitative measure, the mean takes all of those measures, squashes them down, and gives every single data point the same amount. That's what it would be. That's what the mean would imply. Good. Very good. We're going to talk about when we should and or shouldn't use that more today. Now that you know how to calculate it, now that you know what it means, that was a perfect explanation. Thank you, Randall. All right. Pick another one. Joanne.
The median.
The median. What is it?
It's the middle.
It's the middle. It's actually the middle. If you arrange the data, how?
In order.
In order, right. If you have the ordered data, find the halfway point. Now that sounds kind of like what if we do what Randall said, isn't that the same? Not, how come? Why not? Exactly. Depending on the type of data set, they might not be the same number. It depends on the level of skew, which we'll get into today. Good. Very good. Very good. Mode. This is the last one. Tell me all about the mode.
The most commonly occurring.
The most commonly occurring data point. So you got all these data points and they have their own values. It's the one that shows up the most. The most. Good. So those are the 3 we've been chit-chatting about. I do want to go back to the way we calculated those numbers from this graph versus the raw data from right there, actually. So that was the raw data. This was the graph of your guys' results. And we calculated it both ways. We calculated it from the raw data first. We had the actual, if you will, the more precise value of the mean, the median, and the mode. And then we calculated it off the group data. How were our results?
Close.
They were close, pretty close. Good. That was fantastic. That was fantastic because very often they're going to hide that raw data from you and only give you a grouped distribution like this. So I want to tell you why it's okay, again, via a demonstration. I didn't quite get to this. Does anybody remember why it was so close? I mean, remember the concern we had was, okay, so we knew with the raw data exactly how many zeros, exactly how many ones, and exactly how many twos, correct? With this one, all you know is you got 11 0 through 2s. They might all be zeros, yeah? They might all be 2s. Taryn.
I was going to say because you took the middle number.
But yeah, but why was the middle number the safest one to take?
Because it gives and takes equally.
Yeah. How likely is it that they're all zeros or that they're all 2s? I mean, it's also not likely that they're all 1s. It's not likely that they're all of anything in that group. But if you take the middle one, you can offset the overestimates by the underestimates and vice versa, if that makes sense. Now, see if this makes sense. I built this, let me see me open it up for you. I built a little Monte Carlo approximation. You can tell me if this is helpful or not. It's not done yet. I want to build more on it. But what I did was, I created, ooh, let me see, kill the lights, make it stand out a little better. If this makes anybody nauseous, you can close your eyes and then later on you can tell me if it was helpful or not. So what I did was, I created a data set in two different ways. The data set's over here, behind, the numbers are 1 through, it's in this column A and B and C over here. So what I've done is, the data values are from 0 to 20. They're randomly dropped into the data set, and every time I press the F9 button, the data set will change slightly. So what it is it's randomly selecting data from a data set and then plotting the results. The front line would be the raw data. Was it somebody in here that asked me, when you make histograms, why don't you just make each bar 1 wide? Was that somebody in this class?
There was somebody.
It was a great question. I like doing that. So that's what I did with this first one. In this particular instance, there were no zeros, there was 1 1, there were no 2s, looks like there were 7 3s, 8 4s, 21 5s, 15 6s, and so forth and so on. So that's what you're actually seeing. Let me make it a little bigger because we're squinting to see it. Hang on. Make it a smidge larger. A little bit better? Smidge better. So that's what the blue histogram in front is. And the average of that bad boy, if you look over at the averages on the right, the raw data average is staying at 10. And that's because that data set is literally as precise as you can have it because you've got the raw data. Fair enough? Raw data, average, boom, 10. Behind that graph, I've made a second histogram that is grouped in sets of, it looks like 0 through 3, maybe 0 through 1. I can't really tell how wide they are. I think they're 3 wide. 0 through 1, 3 through 5, and so forth. So you see how this one back here, the red one says 1? That's because there's no zeros, 1, 1, and no 2s. So there's 1 altogether from 0 to 2. This one says 33 because 5 plus 9 plus 19 is 33. So there are 33 3s, 4s, and 5s. Fair? So what I'm kind of doing is doing the key document with the other histogram right together in the same graph. And the group data average is going to show here. Now as I press F9, I'm recreating the distribution each time. So in other words, think of it this way. If this is the keys in my Tuesday, Thursday class, this is the keys for my Monday, Wednesday class. That's the keys for next term's Monday, Wednesday class. That's the keys for next term's Tuesday, Thursday. I'm just getting new data each time, just like having you guys count something and give me your numbers. This is called Monte Carlo approximation. Badass, you have a whole project devoted to it. Project number 3. We're going to use it quite a bit in class because it's a great way of getting a lot of data very quickly. We did it in 105 quite a bit. Yeah, Michelle's like, old news, got it. we did it quite a bit in 105 to generate that. Holding F9 down.
Times, wasn't it?
Exactly, as many as we need. I can just keep going like this. Now the trick with going like this is, and it's fun, but you can also, actually, you know what? What the hell? Let's do this. This is actually pretty good. Can you see what the point is? What point am I trying to get across here? Faith, help me out.
It consistently stays right around the raw data.
The concern that some of you, oh, Tara, a little bit louder.
On average over time.
Oh, sister, make me happy. The idea, I walk away. Usually I bring a stapler and I weight down the F9 button, but I didn't bring a stapler today. What happens is, we expressed a concern yesterday that our grouped average, our weighted mean, so to speak, was close to the actual mean. But then the question came up, oh, will that always be that way? And the answer is, yeah, most likely. Watch how the group data number changes with respect to the true actual mean. Watch it. What do you notice?
One below.
It seems like on average over time, for every 9.9, there's also a 10.1. And for every 10.2, there's a 9.8. It's hovering right around there, isn't it? Now, why? Let's go into the graph and look at why. Because having the raw data in front of the group data is actually very helpful because we can actually analyze why. So for example, we were concerned, and this was a wonderful concern, that when we pick the middle value of each of the bars, we might miss, we might under or overestimate. Now if you look at the first bar is 3. If you look at the raw data, there's 0, 0s, 3 1s, and 0 2s. Well, that's about as perfect as it can be. We would pick 1 to stand for that whole bar because it's in the middle. Next bar is 39. We would call everything in that bar 4. 3, 4, 5, we'd call them all 4s. Ooh, but we goofed because there's actually more 5s than 3s. So by calling this 4, we're actually underestimating what's in that bar a little bit, aren't we? Keep that in mind. Keep that in mind, okay? Keep that in mind. Next bar over. 253. Let's see, 0, 1, 2, 3, 4, 5, 6, 7, and 8, we're going to call those 7s, aren't we? We're going to call those 7s. But look, by calling them 7s, again, we underestimate it because there's actually more 8s.
But we also overestimate 36.
Right, but if we call them 7, the concern we alleviated yesterday was if we pick 1, that means the 2s and the 0s are going to kind of wash out in that bar. But you have to apply that macro thinking to the entire data set too. Yeah, we might have underestimated here and underestimated here, but where did we overestimate in this particular distribution?
There.
Keep going, keep going. See this bar, this 240? We're going to call that 13, 12, 13, 14. Well, there's actually a lot more 12s than 13s. So the overestimate cancels the underestimate. How about this bar that was underestimated here? Over here. Cancels it, so to speak. And the beautiful thing about this is just bell curved data. It's going to work for any distribution. That's what I haven't built yet. I want to build more tabs. It's the normal distribution. I want to build more. I just ran out of damn time. I need less sleep and more coffee. We'll get there. But the idea is this beautiful result. No, somebody said no, don't do that. Don't. The beautiful thing is, that's the beauty of Monte Carlo. You can see the result kind of show up over time. And it's gorgeous. It just does this little dance. And there's definitely variation, yes? Just looking at that red bar in the middle, 460, 450, 470, 460, 430, it drops down pretty far sometimes, 427. It never drops down to, say, 100. Although it could. It very well could. Statistics says that eventually that will drop and we'll get some kind of an inverted curve. I haven't seen it yet in tens of thousands of trials. Chances are I won't even notice it when it happens because if I'm holding down F9, it's going to go by really quickly. You guys might say, "Did you just see that?" I'm going to say, "Damn it, no! What did you just see?" And you say, "I don't worry. It's gone." It's okay. So this, I guess I built this to address that concern of how do we know it's going to be consistently applied across that? Please!
Isn't this sort of thing like also calculated out through like the stock markets? Because every once in a while you see that huge dip, like you were just describing, that huge dip that happens only momentarily.
Think about this, Scott. It's a great question.
Yeah.
And I don't know the answer directly.
Oh, okay.
I don't think it's the same. And here's why.
Okay.
This thing has no other addressing factors besides the randomness involved in the random number generator in Excel. The stock market, I believe, does have other undercurrents that are affecting it, which I don't understand.
No, well, and what I was thinking is because they have these predictors. They call them predictors, and I think they run off of a similar software, but not
It doesn't
the same.
surprise me because very often they'll use Monte Carlo simulations to model everything from the result of presidential
That's what I was
elections
wondering, yeah.
to the results of where a hurricane is going. I mean, that's when you see a hurricane track, this is what they're doing. They're doing lots and lots of these and they're trying to see where the trends are headed. And the variation is indicated by how wide. So it wouldn't surprise me if they're using a similar model to do that.
Okay.
What the inputs are is what I would question. I don't know what the inputs they're using are. So there definitely is your question is more broad. I didn't realize how broad you were being.
Yeah.
Yes, the answer yes is a resounding yes. I just don't know what inputs they're doing. If you look at the commands I'm using, I can actually show you by pulling this graph out of the way.
Well, and this is just, I mean, I get that this is just
Oh,
Excel.
too many buttons, too many buttons.
Oh.
Right.
Excel.
Where did I hide my data? Oh, there it was. Right there. See, those are the commands. That command right there generates bell-shaped data. and then this guy right here generates from a z-score converts it to a raw score. So that's what I'm using. But you notice the first couple letters in here are rand, R-A-N-D, R-A-N-D.
Random.
That's a random number generator. So that's my only input to those random number generators. Everything else is just a function of the die falling on the ground. Cool. Now, I do want to chit-chat about group. Let me ask you a question. Do you guys buy that more now? The discussion we left with yesterday. Yesterday was kind of like taking it on faith. Now, seeing this, did that help? Or are you still kind of like, it's okay to still kind of be like, better?
I think it-
Better. Would it be more helpful? Let me ask you this, because I'll make more coffee. Would it be more helpful to have more tabs with different shaped distributions? So what this is called a normal distribution, a bell curve. What if I made ones with other shapes?
Yeah.
That Kevin's like, no, I got it. I didn't need to see that this morning either. So maybe different shapes, maybe different shapes, maybe different shapes, no different shapes. That's funny, it's tied. Okay, all right. Well, I'm gonna hold off on the coffee for now. If I find some free time, I'll do it, but it sounds like most of you didn't vote, so you might not care anyway, that's okay. So let's shut this down for a moment. I want to do one more weighted average. Now we did a weighted mean, a weighted average, and a weighted mode yesterday. All those things we did on the histogram are called weighted averages.